Hey everyone! Today we are going to be talking about gas laws, or also known as gas variable relationships. We touched briefly on these in class yesterday, but I want to go a little more in depth. Okay, so the first relationship or law that we are going to talk about is in regards to pressure and volume. So let's look at the graph. Just don't pay attention to this over here on the left. Let's look at the graph. Let's make sure we know what it means, and we'll talk about why this is observed. So when you start to look at a graph, remember to pay attention to what is on the x-axis and the y-axis, along with the title so you know what the graph is telling you. So in this case, the title would be along the lines of pressure and volume. As you look along the x-axis, this horizontal line or the horizontal axis, it says volume in milliliters. So as we move from left to right, the volume is increasing. Remember, volume is the size of a container. So as the container gets bigger and bigger and bigger, that's what we're changing here as we go from left to right on this graph. As you look along the y-axis, or this vertical line, or the vertical axis here, it says pressure in kilopascals. Remember, pressure is a force per unit area of collisions of particles with the container that they are in. So we are talking about particles colliding with the container that they are in. All right, so that is pressure. As I look at this graph, I see that as the container is getting bigger, so we're moving from left to right, the pressure is going down. As volume increases, pressure decreases. That is what this graph is telling us. As we move from left to right, as volume is increasing, the pressure is decreasing. Okay? So over here, as the volume is increasing, the pressure is decreasing. You may remember this from math, but as one variable goes up and the other goes down, that's what we call an inverse relationship or an indirect relationship. Let's stop for a second and we'll think about why particles or why pressure and volume is an inverse relationship. So let's think about if we have a tiny box right here. Okay, we have a big box right here. They have the same amount of gas or the same number of particles in each box. And let's say that both boxes are at the same temperature. Since these boxes are both at the same temperature, the average kinetic energy or the speed or movement of these particles will be the same because temperature is what dictates the motion or the speed of the particles. So if we're keeping it at the same temperature, then they're going to have the same movement. They're going to have the same speed. So in the small box, the particles are going to bounce off of the walls of the box pretty often because there's not a ton of space for these particles to move around in. On the other hand, in the big box, since the particles are moving, they are moving at the same speed as the small box, but it's going to take them longer to reach the walls of the container. Because it's taking them longer time to reach the walls of the box or the container, there will be fewer collisions compared to the small box. So when there are fewer collisions, there is a lower pressure. So as you increase the volume, you are decreasing the pressure. All right, the second relationship that we are going to talk about is pressure and number of particles. So let's talk about when we change the number of particles in a container. This graph on the right here is showing us an upward positive sloping line. So let's talk about what this means and let's see what it's telling us. As the number of particles increases on the x-axis, so as we move from left to right, as the number of particles increases, we also see that the pressure increases. All right, we're looking at the y-axis here. Let's use the letter N as an abbreviation for numbers of particles. So the letter N represents numbers of particles. So as N goes up, pressure goes up. And vice versa. If N were to go down, pressure would go down. So when we have a mathematical relationship where both variables are either going up or down, that is called a direct relationship. So let's think about why pressure and the number of particles is considered a direct relationship. The volume is staying constant this time. So let's say that both of these boxes are the same size. Excuse my drawing ability. We'll say that the volume is staying constant, okay? And we're saying that the temperature is staying the same. So if the temperature is staying the same, that also means that the speed of the particles is going to stay the same. Maybe there were initially 2 particles, all right? Right here we're starting with 2 particles. And a little while later we add 3, and now there are 5. All right, let's think about the amount of collisions that there will be in the 2 boxes. So more particles means more collisions, which means more pressure. The third and last relationship that I want to talk about is pressure and temperature. So let's look at the x-axis, temperature in degrees Celsius. So it's increasing temperature from left to right. And the y-axis, as always, is pressure. So we see a general trend here. As you go from left to right, the pressure increases. So as temperature increases, pressure increases. This is a direct relationship. However, you'll notice in this graph that when the temperature is 0 degrees Celsius, the pressure is not 0. Let's stop and think about this for a second. Pressure is all about the motion of particles and collisions, okay? But at 0 degrees Celsius, the particles are still moving. There is no pressure or no collisions only when there is no motion in particles. And the only time that there is no motion of particles is at 0 Kelvin or absolute 0. So at 0 degrees Celsius, the pressure is not 0. All right, so let's review. Pressure and volume. As volume increases, pressure decreases. This is our inverse or indirect relationship. As the number of particles increases, pressure also increases. This is our direct relationship, and this is also a direct relationship. As temperature increases, particle increases, or pressure increases. So as always, if you have any questions, please feel free to reach out to me and email me. All right,